A very warm welcome. Good evening, everyone. It's my pleasure to welcome you all to the second edition of Healthcare Radius Forum. Conceptualizing a monthly webcast series, our intention was to bring forth topics which are relevant and significant to healthcare industry and those which needs open discussion. Our first edition spoke about biophilic design and patient experience, which saw eminent speakers sharing their expertise and experience. Knauf Sealing Solutions has been with us in the industry in this journey as the title partner. It's truly a pleasure to partner with brand, understands the endeavor, theme, and significantly contributes as a team. The topic of discussion today is the silent healer, acoustic design in health environments. While we know that the rest is crucial to the healing and recovery process, the findings of AECOM studies suggest that too many patients are exposed to unwanted noise and lack of privacy while they are attempting to make the journey back to good health. Hospitals are built to save lives and heal people. The impact of sound in hospital can be profound for the well-being of the patients beyond the issues of annoyance and privacy. Poor acoustic conditions don't just impact patients' recoveries. Rather, hospital staff also suffer from the stress of working in noisy environments. A good acoustic environment helps staff hear and analyze audible warning alarm sounds on medical equipment and patient call signals. Today, our esteemed panelists from healthcare, architecture and design, and acoustic sectors will deliberate on this very important aspect of healthcare environment. I hope this webcast will help you to understand the subject matter better, and we genuinely hope our next generation of hospitals will benefit patients and staff alike. At this point, ladies and gentlemen, allow me to welcome Sujatha, our editor for Healthcare Radius, to introduce the panelists and begin the session. Thank you very much. I'm very sure that this is going to be one of the most engaging sessions from the Healthcare Radius in Knauf. Over to you, Sujatha.
Thank you, Vibhor. A very warm welcome to our esteemed panelists and the audience. I'm Sujatha, editor with Healthcare Radius. It's my pleasure to welcome you all to the second edition of Healthcare Radius Forum, where we endeavor to bring forth pertinent topics in healthcare sector which needs open discussion and deliberation. We will begin the webcast with a quick round of introduction to our panelists. Dr. Bakul Parulkar, she is a consultant audiologist and speech therapist at Jaslok Hospital and Research Center, Mumbai. She has done a BSc in audiology and speech therapy, and she is specializing in treating hearing loss and disorders that affect ears. As an audiologist, she has expertise in ear examination, hearing loss tests, hearing aid selection, management in ear loss, and she has been practicing since 1983, and she is currently practicing at Jaslok Hospital and Research Center in Mumbai. Our second panelist is Jocelyn. She is the co-director and health interiors practice from Canon Design, Chicago. She has around 25 years of industry experience, and she is the director of healthcare interiors and a leading expert in the healthcare market. Jocelyn thrives on uniting the disciplines of planning, programming, branding, and facility management with a cohesive, comforting interior design. She is especially invested in understanding the unique needs of all users, patients, visitors, providers, and staff in their healthcare settings. Our third panelist today is Sriram. He's the director for design in Sonics. Sriram has been involved in acoustic design since 2000 and has been a part of a number of projects in architecture, community, and industrial acoustics. He has trained under the aegis of Professor Emei Munjal, who is the chairman, Mechanical Science Division, Indian Institute of Science, and Dr. B.R.Sriram, who is a professor, Indian Institute of Technology. He has designed solutions for various acoustical requirements in India, UAE, Qatar, Iraq, Dhaka, Sri Lanka, and Africa. Our fourth panelist is Mathew M. George, who is a principal consultant with MMG Acoustical Consultants, and he's also a member of NICE, ASA, ASTME, and ASHRAE. Mathew is an avid student of acoustic. He is a postgraduate mechanical engineer from North Carolina State University, and he is trained under Larry Royster, a professor renowned in the field of noise control and hearing conservation. He is a principal member of National Council of Acoustical Consultant, member of Acoustical Society of America, American Society of Heating, Refrigeration and Air Conditioning Engineers, American Society of Testing and Measurement, and Institute of Noise Control Engineers. Mathew is interested in promoting the awareness for the need of good acoustic and hearing environment in day-to-day activities. Our fifth panelist is Emei. He is a principal at Helix Healthcare Architecture and Helix Design Private Limited. He has been a member of core design teams of over 80 healthcare facility projects across India, Nepal, Bhutan, Bangladesh, Sri Lanka, West Africa, and Middle East. His healthcare design experience ranged from single specialty daycare health centers to complex, large-scale, multi-specialty tertiary care hospitals. He not only addresses macro-level strategy, planning, and design issue, but he is also exceptionally particular about getting the smallest design details right. His design approach is derived by his belief in down-to-earth pragmatization, simplicity, and honesty in design. Our sixth panelist is Dr. Eddie Lau. He is from Department of Architecture, School of Design and Environment, National University of Singapore. Dr. Lau has over 20 years of experience in developing building energy systems, acoustic, noise control, structure acoustic system. For more than 20 years, Dr. Lau has equipped himself with hands-on experience as an industry engineer and manager, excelling in the fields of architectural design, green buildings, acoustic research, noise control, and high-performance building system. Aside from engineering, Dr. Lau also has made a name for himself as a competent educator and researcher with in-depth background in administration, program and curriculum design, and research project management. And we have Naresh Duble, who is head continuous improvement and marketing Knauf ceiling solutions. He will be joining me in coordinating, in moderating the entire session. And he has gracefully agreed to conduct the moderation for the second half of the session. Naresh is responsible for driving the Armstrong India business for healthcare, education verticals, and marketing development. Over the past few years, Naresh and his team has impacted ceiling installation quality in India, upgrading ceiling installation contractors' skills in India. He has served Armstrong from the early days in India and worked numerous leadership roles in sales and marketing since 2002. This is a brief introduction to our panels, and we will begin with the user segment. Today we have Dr. Bakul Parulkar, who's representing the healthcare facility. So, Dr. Bakul, we would like to know, how is acoustics in healthcare and why does it matter in healthcare?
First of all, thank you very much, Sujatha. Good evening, everybody. And let me congratulate the Healthcare Radius Forum for letting this happen, this beautiful webinar happen. Okay, looking into acoustics, we cannot begin without talking about ears. So let me all just run you through and take you on a tour of a ear and the sound, how it travels through the ear. So it's a matter of how the sound surrounds us, but it's always picked up by the outer ear, which is kind of a funnel. The sound enters your ear canal, hits on the eardrum, which vibrates, sends it into the middle ear, which has three ossicles or the three little wombs, which start vibrating, amplifying the sound, further sending it to the inner ear. The inner ear has a very significant structure called as cochlea. This cochlea has fluid inside it with little cells which are called as hair cells. So once the sound reaches the inner ear, it reaches the cochlea, the vibrations start going into the fluid of the cochlea and the hair cells start bending, converting the sounds into electrical signals, which are furthermore taken by the auditory nerve all the way to the brain to register a sound. So basically, this is our hearing process. Now, what is exactly a sound? Sound generally is, one can say, unwanted noise, or a noise is generally an unwanted sound, which is unruly, louder, unruly combination of improper sounds put together. So one has to also know what exactly happens here. One can imagine, are you aware that almost 1.1 billion youngsters have a tendency to hearing loss in the world? And possibly 43 million of them are between the age of 12 and 35, all because of the unsafe use of noise, sounds from the earphones, sounds which are exposed from the, let's say, sporting events, discos, concerts, and so on. And that's really a significant number. Let me introduce you to what the sound levels are or how the noise is. Sound levels, let's say up to the level of 60 decibels, means maybe our general conversations, general ambient noise sounds around, or even to a certain extent, just maybe one of the cars passing by, are all safe and that really cannot cause a hearing loss. But as the sound level starts increasing, let's say maybe a bike or something, or we talking a little louder, the washing machine, or the air condition, the generator, that all goes up to 70, 75. Till about that time, our hearing is absolutely safe. One can absolutely be comfortable and not really be worried about a hearing loss that's come up. But the moment it goes beyond 75 decibels, 75 and above, that's when one has to think and start worrying about it. Well, sounds like those are mainly, let's say, the railway sounds, traffic congestion, maybe those loud factory sounds, and so on. So these sounds generally range up to the level of 110 decibels. So when you're exposed to this kind of sounds for, let's say, 8 hours a day over a long period of time, that's when the ears start revolting. And they say, well, fine, I'm going into hibernation. The hair cells inside your cochlea start getting damaged. Most of the human beings at birth have something like 60,000 hair cells. As long as they are working well, you hear well. But as you proceed and as the loudness increases, they start getting damaged. Well, but this is not it. There are sounds like crackers, exposure to sudden bombs, maybe siren, and even the aircraft sounds and all that. And they don't limit to 110 decibels. They go far beyond. They go almost up to 160 decibels for what we know. Such sounds are the most dangerous because one hit, one exposure, and boom, you lose your hearing. So that is really, really very something that one should think about and try and prevent to whatever best extent that one can. Well, let me also point out some features like who could be at risk. We all, yes, the general population when we are exposed to this kind of sounds. But yes, there are certain sect of the population who can be at higher risk than you and me. And those are, let's say, those who have a genetic history of a hearing loss. Those who have chronic blood pressure, diabetes, even kidney problems, one can be at risk. Those who are kind of exposed to chemical fumes and all that kind of stuff are more prone to a hearing loss. Those who are taking drugs in the sense medications. Medications can be ototoxic. Ototoxicity is something that affects your hearing levels. So obviously, these are the people who are more prone to the hearing impairment than you and me. Those are the people who get exposed to this. So what is the best approach here? One needs to be extremely alert on this. One has to get a regular investigations done for the hearing so that we know where we are. Because what basically happens is when the hair cells start getting damaged, till about, let's say, 30 to 50% of the hair cells are not damaged, you don't even realize you have a hearing loss. That's a hidden hearing loss which cannot be put down in black and white. So you don't even know your hearing is going down. So one has to be alert here. Let me also tell you, there are this kind of noise-induced hearing losses, which are temporary at times and permanent at times. So what are temporary hearing losses? They're also called as temporary threshold shifts. It's like you and me, we all go to a concert, let's say. In India, we have a lot of exposure to these festivals and noise and drum during those times. We also have this loud noise exposures when we go to the markets and all that, and extreme excruciating sounds there. When we come out of that area for a while, maybe for a few hours, maybe for a day or so, we all feel extremely numb in our ears. That's almost like having a hearing loss. Yes, we do have a hearing loss because at that given moment, the hair cells are bent and they're not in their normal position to again start doing the work that they have been doing. But yes, a short exposure of these types, we can always go back to our normal hearing. But there's something that is called as a permanent damage. Now, when these hair cells get permanently damaged, being exposed to extremely high noises, sounds, and all that, that's when it is an irreversible hearing loss. And one possibly cannot do much about it. I would recommend a couple of things over here, while we are on the subject. I would even say that it's not just the hair cells which get damaged, but in the process, the nerve gets damaged. There are ear injuries which can lead to a permanent hearing loss and so on. So it does make a lot of difference when all these things are happening at one given time. I feel one should always remember how to take care of it. So there are a few tips and points that I would rather state out here. Try and move away from the noise. Try and take breaks between the noise. Try and wear ear defenders or protectors during this time. Yes, ear defenders, we all think about those really big ear muffs which can protect our ears, but that's not the case anymore. Luckily, now we have tiny ear defenders. Let me just show you. And they are so beautiful. They are so cosmetically beautiful that you don't even notice they are there. And they are anti-allergic, they are soft, they filter the outside noise and air. They give you the comfort of listening. It's not like old times that you feel your ears are plugged and so on. So there's no harm in using this kind of ear defenders. And they have specific means of controlling different types of noise. These ear defenders also come for the ambient noise which is there while you sleep. So you don't have these sleep disturbances. They can control the factory noise. That's a different type of a sleep ear defender. You can
Dr. Bakul, if I may interrupt you for a moment, I would like to know specifically how would you, is there any tips that you want to do, to specifically for the hospital environments, because hospital environments do have a lot of noise that is happening. So what are you recommending on that?
Right. Okay, fine. So it's not just the hearing loss that you get from loud noise, but as we proceed further, you also get other health problems due to the exposure to the loud noise. Like, let's say we get hypertension, we do get heart problems, we get psychological anxiety issues, irritability, annoyance, and so on. Me being an audiologist, let me tell you, coming to the hospital concept, generally hospitals in most of the places are placed in such a place where there is a lot of population. So obviously, when we look at the hospital, the outside noise is as loud as the internal noise. So we are in a noisy environment, construction sites and traffic and also the railway. But as you come inside the hospital, it's no other different story. Being an audiologist, I work in a sound-treated area. The sound-treated area, which has no sounds, no noise, good reverberation and absorption and echo controls. And my room also happens to be suspended from all six sides. So while I'm in there, I'm happy. The moment I step out, I start hearing my patients, my healthcare workers, my other equipment making tremendous noise. I visit my wards and I see my patients are uncomfortable thanks to the ventilators, the equipment making so much noise, the healthcare workers' interaction, the relatives making too much noise. And somehow or the other, this all needs to be controlled at some stage. And how? So these are
Okay, so these are the concerns when it comes to the healthcare providers. So let's go to Jocelyn, who is into the business of designing hospital structures. So Jocelyn, understanding acoustic comfort means to comprehend and differentiate noise and its impact on health, safety, and well-being. So to achieve this high-performance acoustical design in healthcare facility, it's a challenge, and that often requires decisions which balance competing interests such as visibility versus enclosure, surface maintenance versus sound absorption, and initial construction budget versus the long-term value. Could you give us an insight into how Canon Design successfully incorporates acoustics into your hospital projects?
Certainly. Thank you, Sujatha. And thank you all for inviting me to attend and to share my perspectives on this topic. This is particularly a critical topic, I think, for healthcare. No matter where you are in the world, we're all facing these issues associated with increased noise in our healthcare environments. And we recognize the impact that they have on well-being and health, looking to try to avoid that as much as possible. They're chaotic, active environments. And what we look to do is to try to balance between all of the factors that we mentioned. We need to create spaces that are quieter so that good communication can occur, whether it's between care providers or between a care provider and a patient and their family. So as we look at an approach to this, we really do focus primarily on designing to accommodate those tasks that generate noise and require the most concentration. Areas such as team collaboration spaces, that might be a nurse's station, it might be meeting spaces. If we are able to create more of an enclosure for these areas with sound absorbing materials, such as a good acoustical ceiling or other wall materials that can help to absorb sound and to prevent that transmission from leaving that room, that will help in terms of controlling some of that unnecessary noise. Also looking to provide spaces for families. Families want to be a part of the entire process. They want to be with their family member in the hospital, yet at the same time, they can certainly be distracting and causing a lot of other noise that may not be wanted. So we look to find places that family can be, that's close by, that's separate from the care environment, that helps to keep that activity a bit under control. And then areas where certain concentrated tasks are required, such as dictation, telemedicine, other things such as that do require enclosed spaces that are acoustically controlled. So we've looked at a number of different ways of incorporating these things, and there is definitely a balance between the types of materials that are needed to prevent the spread of infection and also to make sure that a space can be maintained. Those are often at odds with good acoustical materials. Those that you need from a maintenance and infection control perspective need to be smooth. They are generally hard surfaces and they reflect sound. So most of the areas that we need to focus on do certainly involve a good quality acoustical ceiling that has able to control a lot of that noise that's generated. We also look to include other softer materials where we can. Privacy curtains to separate between patients can also help to stop some of that to a degree. And in areas that are open, where multiple patients are in an area together, we've also started to include partition walls that are partially enclosing that patient, just maybe at the head of the bed for a small distance, just to allow that area around the patient's head to become a little quieter.
Thanks, Jocelyn. Emei, you have been a member of co-design teams for over 80 health facility project sectors. So the hospital environment works in a paradoxical situation of being in a place demanding special conditions of acoustic comfort, of noise levels that respect recommendations established by the technical standards, and on the other hand, being in a place with components with equipments that produce extremely noisy conditions. So how do you deal with this constant dilemma of several demands when it comes to accommodating acoustics starting from the planning stage? Emei?
Yeah, thank you for including me in this panel. Good afternoon, everybody. Good evening, good morning, everybody, wherever you are. Well, I would like to say that acoustics is a subject, as Jocelyn and Dr. Bakul had mentioned, that it's extremely sensitive aspects of the healing environment. But I think we need to step back and look at the overall scenario of how we go down to addressing the issue of acoustics in healthcare. So I would like to touch upon three aspects. One is as a practitioner in India and in the surrounding regions, I would like to briefly highlight the environment in which we designers, architects are working when it comes to hospital projects. Now, whenever we start a project in India and similar countries, other developing countries, what's happening is that, well, there is, to start with, besides the ambiguity in programming, most of the times there is intense pressure on timelines. So the 90% of the times when we start a project, the client's first question most often is, how long will it take for the building to be constructed? It's more important than asking a question like, how long will it take for you to design? The more important for the client is, when can they start construction and when can they finish construction, which will have a positive impact on their ROI. So that's one thing that needs to be addressed very seriously by all concerned. The second part is, okay, when we start a design, we start concept, they say, okay, go ahead, we approve the concept, go ahead, when can we have the tender drawings? So there are a lot of shortcuts. We cut through many steps from concept to tender. So there's hardly any time for the design team to deliberate on the design, coordinate with all the disciplines, not only just architecture, but also interiors and MEP disciplines. So we rush through this process of design. We do our best. And what helps us in our cases is that, well, we've been doing hospitals for so many years and so many projects all across the country. Many a times we are able to jump from, okay, concept to tender drawings in whatever manner possible, because we are given this very strict timelines, because early commissioning and ROI is extremely important for all the promoters. So that's one aspect. And another very important aspect of this project, hospital project, is budget limitation. Limitation as in, if I have say $100,000, 50% of that goes into medical equipment. So it's only the balance 50% that we are left with, designers, planners, engineers, everybody to work with to create that dream project for the promoter. So that's another challenge, but we'll have to, we'll have to work around that and find ways of addressing those issues. And many a times, a lot of clients, especially in the metro cities, they will say, we want international level design. We want to conform to international guidelines, whether it be the European guidelines, whether the Australian, American guidelines. They want to follow all that. But then those have implications on the project time, design process, on the project cost, and the space standards. Those are multiple implications. So those are the experiences that I have seen over the years. Then coming to the planning part, the planning overall site master planning part, sounds that come from the streets are mostly, like Dr. Bakul said, noises. They're not pleasant sounds, they're noises. So the building, the hospital building needs to be protected from this exterior sounds. So what's important while doing the site planning is that we need to very carefully look at the building orientation to ensure that the longer face of the building, the larger surface of the building skin is not exposed to those sounds that come from the surrounding. So if a building is aligned parallel to a main road or a main street, there's a maximum impact of exterior sound on the building. So there's a much higher chance of exterior unwanted sounds entering the building. As opposed to that, if you orient your building 90 degrees perpendicular to the street, then the impact of sound is much lesser on the building interiors. So from a planning perspective, a building location perspective, I think that's important to consider. And besides that, you have other tools like creating barriers using trees and vegetation to absorb the surrounding sounds and prevent those from coming into the hospital environment. Then when it comes to the building skin, well, the sound needs to be dampened. So we use insulating materials. It could be ventilated materials. It could be insulated, double glazed systems. So those will kind of cut down on the sound level that enters the room interiors.
So we have a question related to that.
Yeah.
From one of our audience. It's Salil Chaudhary. He's asking which materials should be used during construction, or what should be the thickness of the walls to ensure minimum sound transfer, as using acoustic materials or rock wool increase the project cost. So do we have any other alternative?
Oh, there are many. I think there are multiple levels at which we need to address this, right? From the location of the building to the location of the high side equipment like the chillers, the generators, all that. And then we get on to the building skin, then we get on to the building interiors. The building interiors, we have 100 variety of materials that can help us in with the acoustics of the facility. So if you're going in for, say, gypsum board ceiling, it reduces sound. If you go in for the gypsum tiles, insulating tiles, that reduces sound further. But the maximum impact happens because of gravity. People walking on the floor, the corridors, the lobby, machines being rolled on the floor, equipment being rolled on the floor, beds, trolleys, all that being rolled on the floor. So they create the maximum amount of sound. So the floor needs to be sound absorbent. In India, what happens is most of the promoters, they want free maintenance, smooth surfaces. Like Jocelyn has said, smooth surfaces, easy to maintain. So, okay, vitrified tiles, non-absorbent, very easy to maintain, but then ignore the impact, the consequence of that, which is more sound in the corridors. So,
okay,
we recommend materials like, PVC, vinyl, linoleum, rubber. These are excellent sound absorbing materials, and they not only absorb sound, they also are impervious, and also they are soft. When somebody falls, they don't hurt you. So it has a lot of positives. Partitions.
So we have some acoustical consultants who will be answering on those questions about the challenges that are faced by the designer. So Jocelyn, you have a question here. How do you define a good acoustic material? Can you share some examples which can be retrofitted?
I think when you look at trying to identify acoustic materials, there are two factors that need to be taken into account. What are those materials that can control sound transmission? So as Rang was mentioning, the transition that, or the sound that might transfer between one space to another, those materials can be some sort of insulating material between a partition, or it can be a partition that has no gaps in it whatsoever. Any opening, and the acoustical consultants can certainly speak to this in greater detail, but any openings allow sound to transfer through. The other factor to take into account are materials that absorb sound and prevent that reflective sound from bouncing around in a space. And that is much as Rang was also mentioning, the acoustical qualities of the floor and the ceiling have the greatest impact on controlling that. Flooring materials can help to control that noise, such as rubber in particular, I would say is probably one of the higher rated products in terms of controlling and absorbing sound. And then then looking at acoustical ceiling products that have sound absorption qualities can help to reduce that as well. One other aspect that can be taken into account is using some type of an acoustical wall panel in certain areas that can help to also prevent that sound from being reflected in the space.
Thank you. I hope, Saroj, that answers your question. So before we move on, we would like to show a short video clip which shows sound levels in hospitals. Naresh, if you could please do the honors.
Correct. So thank you all. Thanks for understanding the sound levels, the science of sound and hearing, impact on human, and sound affects us cognitively, behaviorally, psychologically. Whether we like it or not, sound around us keep on affecting us. And we are seeing the design limitations and approach which we have toward this particular aspect when we go to the building. I'm going to show you some of the clips, which are audio clips from India, from our hospitals, and also one small TED Talk clip, which talks about sound and designing, and sound and hospital rather. So hospitals are for patient. The purpose of organizing this or having this webinar or web series where we are going deep into one subject, so such that we can impact the quality of our buildings. And we have seen what havoc has laid up right now when the infrastructure has not really sustained to. And that answers the question which Rangima is saying, that when it comes to building, people want to cut the cost and not really getting present that end of the day, that is the building which is going to stand for next 30, 40, 50 years in a city. The most important building in a city is a hospital building, because everything else can go wrong, but hospital building need to stand in the city with respect to fires, seismic, performance, acoustics, and stuff like that. So future of hospital is no hospital. We don't want to build a hospital. We don't want to go to the hospital. Ultimately, it is for the patient. So let's see what kind of environment wants
Preview.
The air quality and infection has become an important factor in webinars 3. So noise level like this, the constant factor when you get into a hospital. This is a TED Talk from a Julian Traeger.
When I was visiting my terminally ill father in hospital, I was asking myself, how does anybody get well in a place that sounds like this? Hospital sound is getting worse all the time. Noise levels in hospitals have doubled in the last few years. And it affects not just the patients, but also the people working there. I think we would like for dispensing errors to be zero, wouldn't we? And yet, as noise levels go up, so do the errors in dispensing made by the staff in hospitals. Most of all, though, it affects the patient. And that could be you, it could be me. Sleep is absolutely crucial for recovery. It's when we regenerate, when we rebuild our cells. And with threatening noise like this going on, your body, even if you are able to sleep, your body is telling you, I'm under threat. This is dangerous. And the quality of sleep is degraded, and so is our recovery. There are just huge benefits to come from designing for the ears in our healthcare.
It's also a factor like LOS, length of stay, average length of stay, which is very critical at the hospital for controlling the infection spread as well as profitability of the hospital can significantly improve if all the patient could sleep all the time. If you have tranquility exist in hospital, the recovery of the patient can be far, far faster. And there are many studies across the globe around this. So if we really see what kind of noise level we have, right, in the basement or
ground floor main building, sound level 75 decibel.
So WHO talk about 35 decibel as a noise level in healthcare facility. We have anything between, I haven't yet to see a hospital which has less than a 50 decibel kind of a noise level. And that precisely like Emei said about the rolling loads and moving traffic, and entire hospital designing has transformed, and insistent need of using the hard surfaces has increased two factors. One is the noise level, and second, the level of we cannot even hear or even talk at this place. We are standing at Siu-Kit hospital entry foyer. This is extremely small 100-bedded hospital facility in a tier 2 city in India. And you see a reverberation time level there is like 5 to 6 seconds. And that's completely dysfunctional because even two people talking in that space will make it sound 10 dB more than normal conversation noise. And as we heard, like 70 decibel, 80 decibel, the first victim the constant victim is the people who run the hospital and the patient, obviously, when they are on the bed. And that noise travel through the corridors, travel through entire building, making that building like a fish market. So there are guidelines, and we will talk more with our with expert in acoustics. But yes, the healing environment in the hospital is at the cusp of multiple factors. And one common factor, which is invisible, is the sound, and which has been neglected through the years up till now when it comes to especially Indian building, I can say, but yeah, foreign buildings, we can get it from Jocelyn and how to mitigate those things. But staff effectiveness, their efficiency, their productivity, their satisfactions, everything improved dramatically once you are in a quieter environment and a functional environment. There was a hospital building where when we interviewed them for the National Building Code studies, they say it's impossible to speak at a lower voice level. They just get habituated to shout and take around beyond 60, 65 decibel kind of a noise when they go there. In India, we got one question, right, Sujatha? What are the guidelines we have from one of the members?
Yeah, Chandrasekhar Jadhav had a question on, he had sent across a question as we could have recommended acoustic level in terms of decibel level as acceptable in various functional areas of multi-speciality hospital. If not yet in place, a body or a forum like today should evaluate the opinions and chart plans according towards it. So right. I hope he's online. If you could answer that question to us. Right.
So this chart, which has given by RFHHA, and this is RFHHA has done for 3 or 6 different countries in India. They have done it. I was also part of a IGBC of a healthcare rating system. The similar guideline exists for what volume of the room, what should be the background noise, and what is desired reverberation time level for that given space. Now, these are output-based factors, as in we wanted to see that as an output coming. So there are software tools, and we will get from our consultant how do we go about this. So entire hospital designing is shifting to a human-centric well-being standard, which is a post-occupant satisfaction level of a people. That's a new definition of a green building. Is no longer the carbon counting alone which matter, which is important. But yes, it doesn't alone matter, because if the people who are running the hospitals, people who are running the facilities, if they are not satisfied, not productive, then the whole purpose of designing and running that place is at question. So indoor air quality as well as satisfaction level around sound and acoustics is a new in factor for getting to our next level of buildings. And we have Eddie Lau also with us, who is in academic, as well as he has worked with me for National Building Code in India when we were designing. I was part of a technical committee here. We got a very good code for 0.6 seconds of sound in the learning places, because many of you who was attending this conference also are in charge for a education block next to the hospital building. So we will get deeper into the next sections, as in what are the ways we can achieve this, what are the challenges we have seen in a greater length, and we will discuss how the strategies toward that can transform our new buildings and also the retrofit building. Before getting to those questions, I just wanted to show you one glimpse of a small 80-seater classrooms in a learning place. This is not a medical college, but very similar to a medical college.
Artist study, IISCR, first floor, 110 classroom. Ceilings are gypsum fitted, doesn't give acoustics. We have best speaker on the wall, but if room is dysfunctional for reverberation, it doesn't help what speaker you and sound system you have. For such a small room of 80-seater, you don't need speaker. What you need is classroom design for reverberation time of 0.6 seconds.
So with that, I stop my presentation. So we'll come back to the discussion part of it. Those are the glimpse of what we have in our country when it comes to healthcare building, when it comes to education block, and the entire quality and efficiency of learning, the staff, the people who run the hospital, and people who actually get ill in the hospital. So with that, I'll come to Sriram. Sriram, what do you think, like these guidelines which we have, how do you recommend to go about implementing those guidelines? One thing is awareness, and some program like this, even IGBC rating systems is trying to build awareness. But in your opinion, from your experience, how do you recommend us to the audience to really think about this?
Thank you very much. Hello, everybody. I think this is a good space to impress upon people, at least decision makers, to ensure that the acoustics of a healthcare center is given the right importance. See, acoustics or sound is taken for granted by all of us. Given a choice, I think majority would say more often than not, an eye is important than an ear. But I think the TED Talk clip that you shared was very apt. It said how important it is for a person to rest and sleep while being in a hospital. Now, modern day hospitals are nothing short of factories. They are industries. The kind of machineries that go into these places are, they are very noisy equipment coming in. You have HVAC unit equipment coming in. You have the boilers, you have the pneumatic equipment coming in. You have the rooftop chillers. And these are the equipment itself per se that produce so much of noise. And it's so imperative. You showed a table there about what should be the background noise level that needs to be achieved inside some of the spaces. So to achieve that, we have to control this noise. When I say noise, like Dr. Bakul said, noise is an unwanted sound. But what is unwanted? How do you classify unwanted to wanted? It's a perception. One man's music is another man's noise. So you have to have guidelines to define what is noise and what is sound. That is where the guidelines come in. Otherwise, it's left to each person's perception, and you will not be able to make a head or tail about the data that's being shown. So I think there are quite a bit of standards that are coming in. They're rewritten and they're progressively being updated to ensure that we have a good environment in a healthcare center. But having said that, I think this opportunity I should not miss out in trying to emphasize the need for acoustic design, especially designers who are here, architects who are here, consultants for healthcare projects. So you have noise sources at multiple levels in a healthcare system. One is, of course, the traffic noise coming in, the location of the entire space. How do you build the entire facade system? How do you stop noise from coming out from the outdoor space? Second is the equipment noise. You have a complete floor that is dedicated for machinery. Now, when I say sound is based on frequencies. It starts from 20 hertz to 20,000 hertz. Technically, is a human threshold of hearing. 20 hertz at the lower end to 20,000 hertz at the higher end. But as you age and other things, that keeps changing. But so, what is the kind of frequency that you would want to attack to ensure that particular frequency is cut off? Humans tend to be most sensitive in the 1,000 hertz bracket. We call it the mid-frequency range. Anything lower than 100 hertz, we would call it low frequency. Now, all the machineries, majority of them will be in the low frequency range. Low frequency equipment induce vibrations. Now, vibrations, they tend to vibrate the floor, they tend to vibrate the glass facade. You have to control vibrations there. Sound is nothing but a vibration. When I said 20 hertz to 20,000 hertz, it's a vibration. If I can vibrate my hand at 20 cycles, you can hear it probably. But so that's the nature of it. So if you have a AHU machine kept somewhere, see, you have a ward or a operation theater somewhere here, and right above that you have heavy equipment machinery room. It's so important that that vibration or the noise does not trickle down into that particular space. You don't want the noise to disturb anything. So appropriate measures have to be taken. I think Mr. Emei said rightly, the next level of noise would be about people moving on the slabs. You have trolleys going, you have a lot of people running, whatever, you have equipment being dragged on floors. So the impact noise is coming from the floor to the bottom level. So it's important what you have, what are the kind of rooms that you have downstairs, and how do you tackle that particular noise from the source itself. Now you have trolleys moving, you have people, a lot of people, footfall noise. So you need to have a layer somewhere between the floor, the finished floor level to the slab somewhere to ensure that the noise is not trickling down. Of course, I already spoke about the machinery noise, what needs to be done in terms of vibration isolation. Maybe very noisy equipment, they need to have an enclosure by themselves. We have, during our course of many design spaces, we have come across very strange problems. Somewhere in the Gulf, we had a hospital that's coming up, and right outside, a 10-meter distance away from the glass facade was a metro line. It's not even a station. The metro is zipping past that. We could measure inside the room when of course, it's a glass curtain glazed facade, and it was 86 decibels. 86 decibels in a ward, in a sleeping room, in a OT, whatever is coming there. That is, that is definitely not the way it should be. So designing of the space matters. Now that hospital has to come there. We cannot tell the client that you move the hospital from here. So what are the rooms that can come into that particular side of the that facade side? So that needs to be planned. So the many equipment that the hospital, the medical facility equipment itself are noisy these days. Could be the MRIs, could be the new CTs. It depends on how you plan the entire facility, where they are placed. They cannot be placed nearby, sleeping quarters or any operation theaters. They need to be placed in a different corner of the entire building. Then the entire MEP facility, there could be a DG facility coming in. So planning the entire hospital for noise and acoustics is very, very important. And Mr. Rangmai was saying this, that planning, and there's a lot of pressure on people to complete projects on time. Of course, the economics comes into play, but an acoustic consultant, an acoustician's inputs are must from the planning stage. It's very, very important to come to that. And of course, the next level that Naresh, you were talking about is indoor noise quality, and those spaces that you see in the reception areas or nurse stations, like Jocelyn was mentioning. Sound absorption boards are required to ensure that the reverberations are not high, because whatever we hear right now is always a total of the direct sound coming and the reflected from the room volume. Anybody, you are sitting in your room right now and hearing to me, it's from the speakers, the sound coming out, that's the direct noise, and what is reflected from your walls and the ceiling coming back, put together is what you will hear. So the direct noise you can't help, it's always going to be there. But the reflected noise is something that you can cut so that the amplification is stopped. Now hospitals becomes a little more tricky because you can't use anything and everything as materials, because I think it should be antimicrobial, these are the, so you need washable kind of surfaces which don't augur well with acoustics. So anything washable, anything water running is a problem. So probably you need to have, of course, good companies, I think you were mentioning Armstrong and others, they have come out with boards that are antimicrobial, that can be scrubbed, that can be washed. So it becomes imperative that these are the things that are said by an acoustic consultant during the project. And you need to define the acoustic design criteria. I think the criteria can only be designed from an acoustician's perspective itself. They have to be part and parcel of the project design.
Sriram, there is a question. There is a suggestion which has come from Aniruddha. He's saying, would you agree that there should be standards for medical equipment manufacturers with regards to the sound their equipment generates? There are some sounds like monitor alarms, etc., which cannot be dampened, but there are others which can be addressed. Do you agree with this?
I mean, absolutely. Not only do I agree, it's already happening. I think every medical equipment that are being manufactured from any known companies, they will have to have a noise rating. So this rating will be stamped onto the machine before they're sold itself. So yes, they have to have this particular, they have to say beforehand what is the sound that that machine is going to generate. Based on that, where it's going to be placed and how they have to be, that is the designer's, that is what the designer comes into. But yes, the machines have to be labeled with the noise power, sound power rating, and it is already being done.
Second part was there are some sounds like monitor alarms, etc., which cannot be dampened, but there are others which can be addressed.
Yeah, correct. In fact, the TED Talk showed that. I'm sure these days the beeps from those machines are not as, I mean, they're not so very noticeable as it is in that particular talk. As a period of time, they have also changed. But nevertheless, if you go into an ICU, there are a lot of monitors with beeps happening. Like I said, you cannot control the direct sound. You can always control the reverberated sound by having the right material in places so that it doesn't amplify the entire sound altogether.
Blocking of the sound as well as absorption of the sound, which is extremely critical when to mitigate acoustical requirement for different zones in different rooms, is what I'm really getting from the way you are saying it. And the guideline by the side and the considering the right stage can really transform the way the space can experience, right? In the first place. Correct.
That's
yeah.
Right.
Yeah. So I come to Mathew. Mathew, is it easy to like retrofit or do right for the first time? And you have experience of working with a lot of people calling you to, correct the situations and things like that. So what kind of major control you can give it to the hospital administrator or owners of the hospitals and people who run the hospital, like, Dr. Bakul, what do you want to say about this?
In one word, I would say it's complicated. For reasons being, retrofit is always a headache. But if you start at the design, it simplifies a lot of the. I remember my mother used to say one simple thing: you come to me early, I'll give you a pill. But if you come to me late, I'll do surgery. So the simple principle applies to us as acoustical consultants also. So if we come in early, we help clients understand what are the consequences of selecting and deciding things. And one of the most important things that I'd like to highlight, which many of us know, is that hospitals are silent zones first.
Correct.
If being silent zone, then the requirement of every equipment or whatever we try to put has to first of all meet that expectation. No, it is not easy, but it is what we call as an ongoing exercise of making sure that the incoming equipment, incoming materials do start to see lower selections of noises. I mean, those are the things that you can do. You can't do it on the first day. Those are things that you have to plan for and do it as a long-term exercise. Any institution does not have the funds immediately. So it needs to plan that and decide what needs to be the next course of action to improve. That's what I would say.
Yeah, I think getting this why is very important when they are putting.
Naresh, there is a question for Dr. Bakul. She will have to leave because she has a teleconsultant. So I'll just put the question across to her. Dr. Bakul, this is for you. What is the most sensitive areas in hospital where acoustic treatments is a must?
I must say my own department, Audiology department, where we do hearing evaluations to precision. We need completely treated, sound treated walls where there is no reverberation, there is sound absorption to a particular level. There are no vibrations which are coming in, which can interfere with the hearing evaluations of a patient. And thereafter, I would definitely recommend the ICUs. ICUs are seen the equipment making tremendous amount of noise and sound, which can affect, I feel, the sleep of a patient, which can affect the recovery of a patient to a certain extent. And though there are certain sounds and equipments which we cannot stop the sound from. But yes, like Mr. Sriram said, yes, we are coming up with a lot of equipments which has limitations and ratings on the amount of sound that one can have in this environment.
Thank you, Dr. Bakul. I hope, Bhavin, that answers your question.
Yeah, Vilas also gave a standard around beeping sound. Thanks, Vilas. Coming to Dr. Eddie Lau, at a design stage or putting a concept for a hospital building, what kind of
Naresh, sorry, Dr. Bakul wanted to say something.
Yeah, Dr. Bakul, sorry.
I just wanted to point out something very funny. When there were these surveys going on to control sound and environment in a hospital environment, they came up with a equipment where something that is very well known as a sound level meter, but something that judges it. And when the sound would go higher, the equipment would give a beep to indicate that no, you need to have a softer sound. But at the end of the whole thing, they realize again that beep is interfering. So the next step they went to is a sound level meter, which judges the sound, starts with a green signal, which is indicative, not making sound, just indicative. As you keep like going higher in the decibel levels, it would show amber light. And the moment it goes red, everybody around is alerted. So people are trying their level best, different equipments, they are trying their level best to do the needful.
Correct. And that was a suggestion for IEQ standard that to allow platinum rated or green rated building to have lights in the critical areas. So as everyone can see the light and know where they stand. And that's the one mitigation which is in action right now. So that can be implemented by any building with much cost. Yeah, thanks for that suggestion.
Thanks.
Yeah, correct. So coming to Dr. Lau, so what are the different zones and how do you really treat sound differently in each zones and what's the importance of it? How do you approach that from a design perspective?
I think there's a different, as what you in the discussion, different room and different they have different function and requirement for the sound. So you put out some of the standard in India, and also I do think in US also have another guideline. They also mentioned that the criteria for different area. Some areas certainly, if you talk about individual room, their acoustic requirement may have it means the speech intelligibility may not be an issue for a small room, but for the sound transmission coming from the corridor and nursing station may be a problem, so that we may need to treat the corridor. For some of the another type of room, say for example the lobby area or something like that, such kind of large volume. So that will have induce a lot of the noise coming from the occupants here. It means people there, you have a number of people here. We will generate different kind of noise. I'm not sure that in the panel or the other audience, they know about the Limburg effect. Limburg effect means that if there are more and more people that in the area, the noise level will increase, so that you need to increase your voice. So this increase your voice or voice will also increase the noise level. This will become a very adverse cycle. If the noise level increase, you are shouting. So that will happen is that if your design not doing good, as what in your example that the volume is quite large. In your presentation, you just show the volume quite large. So if there's a no absorption, so that will definitely induce a lot of the vibration. That when people come, say full house or when you have a full occupied, so that will become an issue. You cannot communicate. Certainly, if the volume, what we suggest is certainly we put absorption material, and also the volume should not be too large. Naresh, your mic is muted.
Yeah, so privacy when it comes to consulting areas, no distractions and annoyance when it comes to the rooms, clarity of sound when it comes to the large volume like ICU, or a wards. So coming to Jocelyn, typically in India, we found when we are doing a building, we do one ceiling product for the entire 20,000 square meter. even though it's an Armstrong ceiling, first it is moving from a hard material which resists water and all that kind of concept to coming to a modular is first level of migration for new hospital. But then can you just share how do you really treat the question which I asked Dr. Eddie Lau, different zones with respect to materials and design philosophy?
Certainly. When we approach a design for a hospital, we take into account which areas require greater acoustical treatment because of the activity occurring. That ICU was mentioned before by Dr. Bakul as one of those areas that's often forgotten about in terms of acoustical design. So that may be an area that we focus quite a bit on, and we would specify a ceiling product in that case that is both a highly acoustical product, yet also is able to be cleaned and meet the infection standards that are required. There are other areas that don't need as high an acoustic rating, and it may be a gypsum ceiling, it may be a different type of acoustical ceiling product. So it's a balance between looking at what's required from a specific standpoint from the care that's being provided there, infection prevention and other things such as that, and then meeting the acoustical needs.
Yeah. So, Sriram, when it comes to the rooms, how do you really want to guide people to measure the STC, or how do you want to, if they want to do it in a current building or designing a new building, do you want to say something about that? One is absorption of sound, second is blocking of sound. So there is a RT, we come to know about reverberation time, we come to know about background noise. How do you really come to really designing this and specifying a test around this, or how to go about
I'd like
checking
to add on one more question to Sriram onto that.
Yeah.
In case if a hospital building is already existing and if there is a metro which is laid later, what do you do? How is there an option to modify? How do you kind of adjust to those kind of situations? This question is from Rangarajan.
Yeah, like you rightly said, we need sound. I mean, sound as much as sound absorption in a space. We spoke more about sound isolation is, if not equal, it's more important than in terms of in hospital design. There are very many rooms there, especially I would say consultation rooms with doctors that require so much of privacy. So speech travel between these spaces, it's so important to have the right kind of partitions that come in place. I think Jocelyn was mentioning about how acoustic, you cannot have any punctures in that particular wall, no holes. More so, we also have to choose the right materials also. You can only stop sound from one place to another by either adding mass, or we have to go with a spring mass spring kind of arrangement where you have a wet wall or a dry wall construction. We need to understand what is the kind of sound that is being generated in that. See, for example, if you have a consultation room right next to an AHU room, now the AHU room has a lot of noise coming from the machine itself. So what is the source, what is the kind of sound that is going to generate, and what is the required sound that needs to be maintained in the adjacent space. So accordingly, a partition has to be designed and executed at site with respect to what are the sound levels coming from that particular machine. This data is taken from the manufacturer itself, who would have given it in the design stage. Based on that, we would ensure that the partition is constructed so the adjacent space is not disturbed. Having said that, we would definitely suggest not to have the consultation room next to a AHU room. But if it's unavoidable, yes, this is one of the space. And if it's a retrofit. Now, for the second part of the question, a retrofit, if an existing space is already there and people are facing this particular problem, we need to add something to that particular partition. It's very common these days to have a 50 mm stud with 2 gypsums on both sides. It looks good, but it's acoustically weak. Depending on the type of sound that is there on the other side, we need to evaluate how that partition works. More often than not, it'll fail. It'll fail in a common meeting room. If you have 2 meeting rooms in a corporate office, in a hospital, anywhere, with a simple 100 mm partition, it will fail the entire sound transmission test itself. So here, if you have a machine or something more noisier, we need to do something more to that partition, probably add a couple of more gypsum boards. That could be one of the solutions. And like second part of the question, somebody said if there's a metro already there and you have an existing hospital, what is the workaround for that? That's really tricky. It's not that noise is not simple at all. Of course, there has to be a solution for everything. We can try and stop that noise, but it comes at a huge cost. It's best treated at the design stage itself. Somebody would have envisaged it. But if there's a glazed window, curtain glazing there, and across the curtain glazing you have a metro or a very noisy road, we need to add more layers of glass. We need to add something as a partition to bolster that particular existing partition.
Okay, I hope that answers your question, Rangarajan.
Yeah.
There is one more question from Anil Barya, who is, this is regarding...
Dr. Bakul is supposed to go right now. So before you go, your final word on, can we have some different type of sound therapy within the hospital? What are your thoughts on that? You want to share some ideas around retrofitting and changing the experience of sound?
A beautiful question, I feel. In today's day and age, a lot of things are happening with people keep talking about meditation, prayers, and all those things. And what is it all about? You will always see it's something to do with rhymes and rhythm and music to collaborate with. And that really has given a lot of peace, a lot of stability, a lot of comfort to most of the population of this world with the stress around. Yes, there are things like music therapy, which can do a lot of healing. It becomes easier for a lot of people to start connecting and automatically responding to something that is happening around them. The music also gives a rhythm and comfort to the body, which are tense, and soothes out the general environment as well. So I would always recommend, yes, music, little rhythm, some beats, some coordinations can make world of a difference in healthcare.
Thank you.
All right. So just, I may have to leave, but just a parting thing I feel I should say. So it's time to start designing hospitals, not only for the patients, but for the comfort of our ears, health, as well as optimum productivity of all the healthcare workers as well. Thank you.
Yeah.
Thank you, Dr. Bakul. Thank you, Doctor, for your time and
Thank
being a part of this conversation.
Pleasure. Bye-bye.
Yeah, the medical professionals spend most productive awake time of their life inside the building. Their entire lifetime, the most productive awake time goes inside the building. And that's where it is important that we make it's a satisfying experience to work and be productive. Thank you for that comment from your side. Yeah. Should we open the forum for the panel discussion? You guys discussing different questions which we have.
Yeah, we have one question for Emei. So he had spoken about sound traveling in the plenum. So the space between the false ceiling and the RCC slab above, it could be advisable to have the interior partition travel all the way up to the slab instead of just stopping above the false ceiling. What's your comment on that?
Yes, I think that should be a standard and not an exception. Every partition, we should be able to take it up to the bottom of the slab. And one other thing about the interior planning is that most often we tend to do this single-handed layouts, mirrored layouts. That is back to back, head to head, right? So somebody knocking on the other side, I can hear it. It disturbs me. But if I do a single-handed layout, that is avoided. So the sound transmission is reduced. But then because of reasons, financial reasons, we tend to do this mirrored thing, which is more economical. A lot of services are shared. So those also contribute to the sound levels in a facility, whether it is a hospital or whether it is a hotel room. I mean, it's similar.
Yeah, and hotel rooms remind me, Matthew, you were talking about, because Matthew works across office, hotel, and healthcare. What is your observation?
Well, in my simple opinion, hospitals are, patients are guests also. So if they, and we have to understand that they are at a disadvantage because they have to be there. and it is most critical to see if whatever design we do in terms of making sure that the spaces can be as appropriate as possible, because is sometimes space constraints, selection of materials, all those things causes difficulties. But keeping the patient and the doctors and nurses, that's one thing which I've suddenly just came up, because last week when I was looking at ASA, the Acoustical Society, they were talking about the inability to communicate through face mask and shields, the face mask, the shield, and the bodysuit. So one of the studies that are going on right now is to how to understand and how to see what's the impact of communication through those intermediates and the impact on doctors. So all these things are critical. Some things that we need to understand and see that there is some certain amount of downtime for the occupants, especially the doctors and nurses, so that they are able to recoup and come back into the system. They are also working. So my guess is, as much as a patient, the healthcare providers need also the appropriate downtime to allow them to recuperate, is the word I would say.
Yeah.
Okay.
Right.
So we have 15 minutes now, so we can open up the platform for open discussion. So there are two topics that I would like the panelists to address. One is the eco-friendly solutions that we can have for solving this acoustic problem in healthcare, and the other is the economic factor of it. Many people don't go for acoustic construction because of the money matter that is involved in it. So what are the solutions for that, A? And the second one, the eco-friendly solution for an acoustical barrier. And audience, if anyone is interested in asking questions, please raise your hand. We can open your, you can ask directly to the panelists.
We will have you discussing these topics among 5 of you now. And then after 10 minutes, we can take the question answers from the audience. Yeah, there you go.
I think Jocelyn will agree with me, and Dr. Lau will also agree with me that I think the first and the most basic measure would probably be from exterior to interior, to reduce that sound volume coming inside. I would just optimize the external opening and not give a very large opening beyond what is actually required, especially in a hot country like India. It's a lot of people tend to give very big windows because, okay, they like the expanse. It feels like a hotel room, good view, but then there's a lot of heat that comes in. There's a lot of sunlight. It's too much of sunlight. And for you to have a good view of the surrounding, more than the vertical, I think a horizontal opening works better. Less intake of heat, but more view, but optimize the size so that sound coming in is reduced. So the amount of glass that you need to double glaze, that you need to layer in two layers is reduced. The square footage is reduced. So that is one basic measure I think can be adopted in many of, especially in the smaller tier 2, tier 3 towns.
I think is I think the noise measuring, in fact, we can have a different architecture design to save it if we at the beginning in the design stage. Yeah, generally we have the building setback barrier, we have those kind of the orientation, we have the shielded wall, architecture thin, absorptive balcony. And those kind of if we can design them in the design stage, in fact, it's very low cost and very easy to implement, and also can isolate some of the sound already.
I think I would add on the cost issue, in thinking about the building from the start in terms of where it's sited. How do you organize different functions within the building itself so that they are placed in areas that you can manage the noise that might be inherent in any event, and keeping certain patient areas away from areas that might be noise generating. I mean, that's all part of the planning process that we go through anyway when we're designing a building. So we need to think about the impact of noise and sound in terms of how we plan that layout, just to make sure that we're taking advantage of the most economical way to approach it as well. Many times we look at projects in terms of cost, maybe in a little bit of a different way. And it's not only just what it costs to build a project initially, it's also what it may cost over time and what's the impact of that return on the investment. Can it be maintained easily? Are the benefits seen to the patients because they stay in the hospital less, they receive less medications? Is there any sort of benefit that's seen as a result of that in terms of how acoustics are addressed? Those strategies have been rather successful in many of the projects I've been involved with.
So there's a question for Emei. What should be the optimal build form or configuration of the buildings while planning a medical college campus so that the hospital units does not get affected by the noise?
Well, I think that will depend a lot on the profile of the land, the area of the land, the space available for accommodating the footprint of the hospital and the medical college. So there will be a variety of factors that we will need to consider. So I think it will have to be done on a case-to-case basis. There is no one set of rules to achieve this objective, I would think, because it has to be specific to a particular site.
Dr. Edila, would you like to speak about the teaching block and the importance of sound and how do you really approach? Because you're teaching now also, before you were a professional designing the spaces.
I agree with the previous speaker talk about that. The design is very much depends on the outdoor environment. It's pretty much like you are talk about how to control the air, the haze. So how efficient of the filter you need to use it pretty much depends on outdoor noise level, and then and also the indoor noise criteria. Generally speaking, our traditional acoustic design is based on the noise management approach. It means another speaker talk about, certainly we talk about these noises and unwanted sound, but in our traditional acoustic design, what we use the approach is the energy approach. It means we treat everything as noise. We just bring down all the sound to noise. So the traditional, that's the reason for the, say for example, for those classroom, and we have single speaker, we just have a more or less just have a single speaker or just a one-way transmission. We will consider the background noise level and also the reverberation time is the what we call fundamental criteria for the design. The WHO guideline talk about is a 35 dB background noise level, 0.6 second reverberation time is what the start point. A lot of countries like US, UK, China, they will have their own standard based on the WHO, more or less similar, 35 and 0.6 second. Some other country may use this speech transmission index, STI, as a criteria, but this is a single index instead of two index parameter. Two parameter mean that we have reverberation time and background noise level. Instead of using two parameter, we use single parameter STI to as a criteria for the speech intelligibility.
We are running on short of time. We will take one last question and then we will be closing the webcast for today. So this is from Amar Shetty. Any of the two acoustic consultants can answer this. If you're told to treat either ceiling or wall with acoustic product, which would you choose? Inside a ICU? Given the condition, you are allowed to choose only one surface.
Easy question is more or less we use a ceiling. What we would like to do is we have a simple equation, simplify the equation, Sibin equation. The reverberation time is depend on the volume and absorption. The absorption it totally depends on the area. It means that the reverberation time easy if you are engineer. The equation is the volume over the area. if we get the absorption coefficients, it means the larger the volume, you will have longer reverberation time. If you have more area to put the absorption, you will reduce the reverberation time. But unfortunately, if your volume increase, so your surface area will not increase as fast as the volume. That's the reason I said you also need to control the volume. So where you have the larger area to put the absorption is the ceiling and floor. Generally, floor you need to have a hard surface because you're walking down. You may have the carpet, a little bit absorption, but most effective way is putting on the surface ceiling so that you have large area. You put the absorption material.
I would just add one point here. It's just that maintenance, as you said very clearly. So the ceiling is the safest place to put it.
Okay. Sriram, you have any opinion on this?
I think it can't be different from the other acousticians there. But yeah, ceiling walls, you won't get too much of a space on the walls either. You'll have a lot of lines coming in there, a lot of equipment already placed that itself will be blocking them. It's the obvious choice of the ceiling itself.
Okay. So I'd like to thank everyone.
I have a question for Jocelyn. Coming from for a country like India, such a vast and huge number of people, we speak also loud. Why it is so difficult for architect to go right for acoustics right in the first place? Any opinion, any view from outside on this? Because you have also worked on a few projects in India.
Yeah, I think that oftentimes the cultural norms and standards of an area or a country are taken into account probably first and foremost. I mean, you're designing for people that are using this facility, and that facility needs to be comfortable for them. And in countries such as India, you're comfortable with having your larger extended families along with you because it's comforting. As a patient, you want them there. So I think that's part of the reason why that is looked at probably as the most important thing rather than jumping immediately to acoustics. So acoustics is absolutely a byproduct of all of that, and that needs to be addressed and factored in. But it's a very interesting dynamic when you think about different cultures around the world and how we need to be approaching design for each of them.
Just like SOPs and infection control can be a criteria for getting accreditation for a facility, probably the quality of acoustics should also feature in this. Because if you look at it, I may be wrong, but even in the JCI document, there's only one page, one word which is mentioned in the whole document, which is acoustics, nothing else, nowhere else. I think it is not only here, everywhere, the importance to acoustics has not yet been given.
Yeah, I think I'd want to come in there, so rightly put. I think we should not waste this platform with designers here, decision makers here. When you get to value engineering of the entire project, the first thing that gets knocked out is acoustics. You would say this is a waste of money. So please don't do that. It's so vital for the entire project. And it doesn't add too much to the cost if you've taken it in the planning stage. It definitely is a misnomer that says once you bring in acoustic material and other things, the cost goes up considerably. It is not so. And even if it goes up a little, it is a very important piece of information that it is meant to go up. You're meant to do that particular thing. So I request the panelists at least to consider that, to keep, don't knock off the acoustics, at least from the design for value engineering.
Okay, that's a very good point that you have put, Sriram and everyone else. Thank you for joining us today. May I request the board to present the vote of thanks?
I was like, what do I say? I just was wondering if we can just go on and on. I think in these times, I have to immensely thank Naresh, and Sujatha both, and the team behind, who actually, curated this forum, and especially this topic. That a lot of deliberations have gone, and audience, a very, very big thanks to you for being just there, and more importantly, being interactive. I mean, I've never seen off late so many questions coming. So I think that's a testimony of the fact that our brilliant panel, really kept everybody informed, educated. I think it's very good to see here. I think a very insightful conversation here. I believe we are all going back from these sessions understanding why acoustics has a major role to play, not just in healthcare environments. I thank all the panelists who took time out of their busy schedule to be a part of Healthcare Radius Forum. A special mention to Jocelyn Stroupe, who woke up very early to join us. So thank you, ma'am. Thank you very, very
Absolutely.
much.
It's my pleasure.
Absolutely delighted. And I hope to see you in multiple threads of discussion that, Healthcare Radius and Naresh and Knauf and all of us will be keeping this whole conversation going. Healthcare Forum, is the monthly web series. And the next one, please, ladies and gentlemen out there, please block your date yourself, 24th June. I repeat, 24th June. Naresh has always said and has always discussed and deliberated that we must keep a session which is 1.5 hours. So I, Naresh, completely agree with you now. If you say next time we both have a 2-hour session, I will give it up, because so long you have a content which is so compelling. We'll be updating the topic and panel for the same in our social media.
Right.
So make sure you follow us on LinkedIn, Facebook, Twitter, and Insta handle. I once again very warmly thank you, all my panelists, all my lovely audience, and all the people who asked so many interesting questions, and Sujatha, who really, anchored, and I'm sure Naresh and you really, Jocelyn, there is one word in Hindi called Sutradhar. Sutradhar meaning anchor, who stitches and weaves the whole thing. I think the pair of you really worked so very well. It was such an interesting conversation. I devoured every moment of it. And I'm sure all our lovely audience have equally, liked it and found it very educative, very informative, exceptional consultants, exceptional designers, exceptional solution providers like Naresh. I'm sure we are in very safe hands when it comes to healthcare in this country. So ladies and gentlemen, a very, very, a big thanks from all of us. Stay tuned for more, 24th June again, and watch out the next issue of Healthcare Radius, which will cover exhaustive coverage of this great content. Thank you from us, and thank you all. Thank you very much.
Thank you.
Thank you.